let's talk about finding the magnitude of a vector. So let's say I have a space vector AB that points from x1, y1, z1 to x2, y2, z2. So I don't know where these points are in space. And maybe this vector points this way. And so here's my point A, and then here's my point B. I just need to find the length of this vector. So I just need to find the distance between A and B. And there's the big idea. I just need to use the distance formula. Well, we derived the distance formula in one of our very first videos. So I take the difference in the x's and I square them. Take the difference in the y's and I square that. And then I do the same thing with the difference in the z's. Just using the distance formula, there is the magnitude of that vector. But even better than that, I see the component form of a vector here, right? Vector v, the vector AB could also be represented as x2 minus x1, comma y2 minus y1, comma z2 minus z1. And so if I write down a vector in its component form, right? If I think about a vector in standard position, then its magnitude is even easier to calculate, right? Because when I subtract x2 and x1, I just get a number. When I subtract y2 and y1, I get a number. Right? I just get a vector ABC, and replacing these bits, the magnitude of vector v is simply the square root of a squared plus b squared plus c squared. And these same ideas work in the plane. I just need to cover up the z bit, right? Because the distance formula in the plane looks just like this. The distance formula in the plane, right, looks just like that. And so if I have a plane vector AB, and maybe that plane vector looked like this, I just use the distance formula in the plane. To find the length of that vector. And so that's how we can calculate the magnitude of a vector. So at the end of the last video, I warned you that I'd teach you about one special vector. And so I want to teach you about what we call the zero vector. And the zero vector, denoted with 0 with a vector hat on top of it, or in print it'd be bolded, is simply the vector that points from the origin to the origin. So in the plane, it's the vector 0, 0. And in space, it's the vector 0, 0. And of course, it's really any vector that points from a point to the same point, right? Because every vector can be rewritten in this component form. But the important thing to know about the zero vector is it has length 0, right? Its magnitude is 0, and it has no specific direction. Right, it's not that it doesn't have any direction, right? Because if I'm going from a point to a point, it's almost like I could think about spinning around in any direction I wanted to, right? It has no specific direction. So there's the zero vector, and we'll see it come up every once in a while.